So what we've done up to this point in time is we've taken all these definite integrals and we've evaluated them, and we equated the evaluating of the definite integrals with area under the curve. So if we had some sort of geometric shape, we could evaluate the integral. And then we learned about the fundamental theorem of calculus and how we could evaluate integral with antiderivatives. And so now what we want to do is we actually want to use integral for one of the things that it allows us to do, which is to find the area under curve. Now, areas under curves are interesting, and with integrals, we really have to pay attention. Because if I ask you to evaluate an integral, it's totally possible to get a negative number. It would take the area below the x-axis and add it to the area above the x-axis. And if we evaluate that integral, we should get a negative number. But if we're asked to find the area between a curve and the x-axis, that's like asking for a distance traveled. And distance traveled will always be positive. So if we're asked to find area using the antiderivative, find the area between the curve and the x-axis. Wow, what was that? So here we go. Here's what we're going to do. We are going to put together a real quick x and y axis to have an idea of what our graph looks like. And free OCD kids, if this isn't 100% straight, I'm really sorry. I am not that OCD anymore. I mean, I used to be. I might still be a little bit if you really know me. Okay, so here we go. 4 minus x squared looks like this. 4 minus x squared looks like this right here. And what we've been asked to do is evaluate the integral from 0 to 3 of 4 minus x squared. Now, pause the video, punch this into your calculator real quick, and then come back to the video and just in your mind, look at your calculator and then think about what I'm getting ready to tell you. Okay, ready? Pause. Okay, what'd you get? Did you get a big answer that you thought you were going to get? Did you get negative? What'd you get? Okay. What your calculator did was it said, hey, I'm going to start here at 0, and I'm going to go all the way over here to -3. Or I'm sorry, +3. And I'm going to add up this positive area with this negative area. And so if you look at your calculator, what it's doing is it's combining both of those together. So it's going to do positive minus negative. But if we're asked to actually find the area under the curve, what I need this total area here. I need absolute value of this area and absolute value of this area. Okay? What does that tell us? It tells us that we're going to actually break this integral into 2 right here where it crosses the x-axis. And, 4 minus x squared, what number? 2. So what we're going to do is we're going to look at the integral from 0 to 2 of 4 minus x squared dx. And we're going to add it to the integral from 2 to 3 of 4 minus x squared dx. That gets us the same information that we're interested in. Okay? But here's the kicker. The one change that we're going to make on both of these, because we want total area, that's like total distance. It's always going to be positive. It's like absolute value. Hey, absolute value, absolute value, absolute value. We want the absolute value of these puppies. All right. Now, we're not going to actually integrate absolute value. That's going to be another lesson for another day. But when we evaluate these guys, we want the absolute value. Okay, so I'm just going to get those absolute value lines off. We're going to evaluate real quick. So this is going to be with antiderivative 4x minus x cubed over 3. There's your first guy. Evaluate that from 0 to 2. Plus, and then it's the same integral again. 4 minus 4x minus x cubed over 3. And we're going to evaluate this guy from 2 to 3. Okay. And when we get to the actual evaluation process, that's where we're going to look at the absolute values. So here we go. I'm going to have stop minus start. So 4 times 2 minus 2 cubed over 3. I want minus, and then 4 times 0 minus 0 cubed over 3. There's the first guy right here. And so this is going to, these are zeros, right? Those go away. 0 times 0 divided by whatever, doesn't matter. These are all zeros. So over here I've got 8 minus 8 cubed. Okay. And that's going to be, if I put this over 3, this is going to be times 3, 24 minus 8. So 16 thirds. I want the absolute value of that guy. I want absolute value right here. This area right here is absolute value 16 thirds. I want that. Okay. Then let's evaluate this second part right here. And I'll just do that right here. So that's going to be 4 times 3 minus 3 cubed over 3 minus, and then where I started, which was at 2, 4 times 2 minus 2 cubed over 3. And hey, these guys right here, look, you see anything similar, right? So this is 16 thirds. And for 12 minus 9, okay, 12 minus 9 is 3. So if I get a common denominator, I'm going to have 9 minus 16, which is negative 7 thirds. Okay, I need the absolute value of this because he goes right here. That area is negative 7 thirds. But in order to get total area, I need the absolute value of that. So here we go. 16 thirds plus the absolute value of negative 7 thirds. Whoa. Let's see here. Absolute value negative 7 thirds is going to be 16 thirds plus 7 thirds, which is 23 thirds. So if you're asked to find area, use absolute values. If you're asked to evaluate the integral, then you just do your addition and subtraction just like you learned in second grade.